Okay. Yeah, it's Friday can be busy. Sometimes I know. Okay, so the plan for today, I'm sharing my screen at the moment. Please let me know once you will be able to see it. So the plan for today that we cover a couple of more things on segmentation. And then we switch to other topics. And other topics as and behavioral scoring. And I was thinking how to start with it. I think that first we will cover churn, and then we'll start to behavior scoring, and that's like big topic to finalize during this weekend. So, by the end of tomorrow, we will align on churn, on behavioral scoring, and on segmentation. So let's go to the place where we stopped yesterday. So the thing which we should start with, and that's one of probably the hardest to use, hardest to answer question, which data you should take for segmentation. So yesterday, we took a few random columns. We showed how algorithms work, right? Also, what we did, we discussed that there were some other approaches that people were using: geography, age, gender, and so on, in order to segment somehow customer cohorts based on their physical characteristics. Also, what we did, we had some data already prepared by me, where we had some behavioral characteristics of customers. And so we picked few random ones, checked if we see something useful in it, and moved on. But then, like, was no universal solution, and maybe there are actually no universal solution at all, because segmentation's building block of any kind of other analysis. In most of cases, segmentations are super useful, but it's not the final goal of the analysis. That's why it's so hard to define some good variables for segmenting. And in my understanding, the good variables for analysis really depend on the problem you are working with. If we go to customers, there are at least few ways how we apply a customer data within an organization, and it depends on the ultimate goal of that analysis. So let's say for marketing, I believe if we apply it for a marketing topics, we should use marketing. The most we should think about marketing and behavioral data and all the features which we can extract. If we think about risk topics of the person, we should list all the features of the person which may be associated with the risk, or somehow the triggers of the risk, like suspicious behavior reports, and so on and so on. If it belongs to some other topic, that's pretty much can be related to other data from organizations. So generally, I wrote a list of which should be pretty universal. I was showing it already to you yesterday, of which kind of data can or should be useful. This list is like more for financial sector, but still I think super universal. That's all you can get about the customer personal characteristics, about economic characteristics of customer, about the market characteristics, and geo and demographic characteristics of customers. This is a big wish list. It's almost never available as full list. But what I suggest doing in real life, you take a one pager and write a list of everything what you actually can get. And here's the important thing. You should be able to get the data in a stable manner, that not like some Excel report which some analyst manually generated once in a life, but some stable and reproducible data. That's theoretically what should go into your to the features which go to the segmentations. And as I say, like, it's really depends on the ultimate goal. So for example, if the ultimate goal is optimization of campaigns and you wanna select the customer segments, which and personalizing campaigns per each customer segment, you should link this analysis with a next model. So for example, you will have a two-step solution. First, you will segment people. Second, you will, for each segment, you will predict the probability of reaction to some campaign or reaction to some advertisement, so on. And in that next model, you will also have some data. And for that next model, it's kind of easier to select the data because you are selecting a data which probably can be relevant for a reaction to campaigns or reaction to the advertisement. So the best is to take exactly the same or very similar data. So which goes in the second step model. Then there are some technical tips how to do a feature selection for such cases. So first one, and always the easiest one, is a correlation matrix. So right now on the left part of the screen, you see pretty easy, easily runnable correlation matrix visualized across all features. So the idea is that, well, you shouldn't actually take features which are highly correlated into the same segmentation, unless there are some exceptions. So this visual is part of this R code, which I also shared to you yesterday. So if you rerun R code, you, on like one of the first few steps, you get this visual too. And this is like practically the same features which we were discussing. So here is like total turnover, total income, total output, total savings is the difference between income and output. Saving ratio, so ratio of savings out of total turnover. Standard deviation of monthly incomes. This is a stable income ratio. Number of months which the customer was dormant, cash in ratio, cash out ratio, wire transaction in ratio, and wire transaction out ratio. And one actually I excluded here. So all transaction in a banking, like roughly you can categorize all transaction by 3 types, like cash, transfers, and monetary operations. So basically cash is like all operational stuff. Transfers are like all cards and cash and current accounts and so on. Wire transfers are like large transfer operations and transactions to sending money company to company, customer to customer, and so on. There are a couple of technologies for transfers, but like let's don't go there too deep. And then there are monetary operations, which are mostly investments. So like working with different investment products, some maybe even financial instruments and so Roughly, I excluded here the monetary operations from here because in that data set, they were really rare. So there was very few customers who actually did these monetary operations in that data set. But okay, let's take a look on this chart, which is called correlogram. And as you see, the solidity and the color of this bullet or rounds actually correspond to the level of correlation between some variables. So first guess, what should we not take into account in this segmentation? Looking on this correlogram.
Total turnover.
Total turnover, or we cannot take both total turnover, total in and total out, right? Because first of all, total turnover is a sum, total in plus total out. And yeah, so that's maybe not the best idea to include 3 of those features altogether. In like causal modeling, or like when people are trying to model the impact of one thing in another thing, there is like such a complicated word, but it's I don't have some very good substitute. It's called perfect multicollinearity bias or perfect multicollinearity, which means that like some features can be absolutely perfectly substitute each other. And when you include both of them, at least for some predictive and causal modeling, they are not super useful jointly. Like for example, you cannot put at the same time is male and is female. If you include such 2 characteristics, if you have is male and is female, they perfectly explain each other, because like if you have one variable, then you don't need to know other variable, because if it's not male, then it's female. I mean, there are some exceptions, but like they are rather rare or some missing data. But so maybe this example is perfect in 99% of cases. Yeah, so but generally here's the same thing. We cannot include the variables which perfectly explain each other. What else? What else do you think would be perfect candidate for excluding? Or perfect or good candidate for excluding from this list?
Stable income.
Stable income is highly correlated with total of output transactions. Yeah, total out count. This is CT stands for count. So number of outputting transactions. That's actually pretty interesting. Yeah.
But we removed this, yes, this total amount.
Yeah, we remove this. So like we cannot include both of them, but so if you don't include this one we may include. What else?
Dormancy months and stable income also.
Dormancy months and stable income.
Yeah, there's a red dot there.
Yeah, so it's like strong negative correlation, and yeah, and maybe it even comes from the way these features are calculated, but absolutely correct. So we exclude both strongly positive and negative correlation, not only strongly positive. And yeah, we see that like the more number of months the customer was doing nothing, the less stable income he actually has, which sounds really logical. Well, also we see that like there is a strong negative correlation between cash transactions and wire transaction share. So if people don't use cash, they use electronic transactions. If they use cash transactions, they don't use electronic transaction. At least it's like highly interdependent. So general tips is don't include two highly correlated features at the same time. There are exceptions. There are cases. I know I kind of confused this. First I say use the like don't include it, but then I say, okay, there are some cases when you can include it and it will still make sense. Any idea of what would be the good case to still include some highly correlated features?
I guess when the correlation is not obvious for us.
Mm-hmm. And what do you mean by not obvious correlation?
Like we see some correlations that we did not expect, like some variables which we didn't think could correlate, but they correlate.
Mm-hmm. Yeah. Yeah. For example, I don't know. Someone gave me this example, so I'll just repeat it. So you can find out that some weird correlations which have no theoretical link, like number of birds on the roof and I don't know exchange rate. And okay, this is like still bad example. Somewhere in one of my presentations, I have like maybe 10 or 15 funny facts of funny correlations which don't make sense. But I totally agree with you. Like that.
I think
yeah.
it's when we have correlation, but we don't have causation. Yeah. So.
Mm-hmm. Yeah. So yeah, that's one case when you like can include both when it's like just like correlation, which is just for like for a no theoretical link between these two factors. I see that Ilona sent some link for specious correlations. Yeah, unfortunately, yeah, somewhere from that web page which Ilona sent, I have a lot of screenshots in some of my other lectures, but a lot of correlations, like if you can open the link, there is like chart number 2 shows the number of people who drowned by falling into a pool and films Nicolas Cage appeared in. But maybe it's actually drug station or something like this. Yeah, I think we will entertain ourselves like whenever we have a chance to from all these funny facts. But yeah, so for now, so that's one case. When we still can take into account highly correlated features, what do you think? Like, why would I include in the same segmentation total in and total out, which are super highly correlated? Or yeah. While you are thinking, I will open actually the link from Ilona because it's really funny. And
well, probably you may want to include both the input and output when you think that these variables will put the entities into different clusters. For example, some may be put in one cluster on the basis of income, and some or input on some on the different cluster on the basis of output, if you want them still to be there. Or if your theory says that you must include both of them.
Agree. I think that's like, given your example, that if two things are highly correlated, most probably both of them, like both of the factors, will push some observation into the same cluster. Maybe with some exceptions into different, but in most cases it will push to the same cluster. And here's the idea. So yeah, just visualizing you this suicides by hanging and spending on science. Honestly, I believe there can be causation here, not only correlation. As a person with some relation to data science, I know that science can be frustrating on some points. Okay, so I think when it's actually still makes sense to include it is when you wanna strict on some effect. So for example, if you use a method like k-means, it's not really easy, or it's technically possible, but a bit hard to prioritize features. So for example, in a different statistical techniques, you can put weights on the data. And by setting weights from user, you say that, okay, you know, total turnover is actually the most important for me. So first of all, I want things to be, you know, checked by total turnover. And then by something like all the rest is like less important. So what I can do, there are two basic ways. Well, first of all, I can apply different scaling techniques for total turnover and for everything else. That's like one way. There are also within the within at least k-means algorithm, it's possible to set weights, but they always will be a little bit counterintuitive. And also setting weights, you should make some good guess what this weight should be and so on. So another way how to set a weight in a smarter way is to include correlated variable. So for example, if I believe that total turnover is the most important, and I should first of all look on the size. Basic total turnover is a definition of size. So how big is this client? And well, I can actually include some highly correlated feature additional, which is highly correlated with the total turnover. And then when I'm running my k-means algorithm, as you remember, it was minimization of Euclidean distance or minimization of sum of squared distances. And if I have two variables responsible basically for the same effect, I have a like incentive to decrease this distance more specifically for total turnover. So basically split based on the total turnover more. So this is like one trick which you may use or may think using in your exercises in order to prioritize things. If you believe that like all features are equivalently the same, you should be fine with what you have. Alternatively, there is one additional method for feature selection for unsupervised methods. We will have it in the practical part in the notebook, so I will show to you. But shortly, apply the same feature selection method as you apply for your second step problem. So if you generate segmentation for, what was my example? Campaign optimization, you have a model after. So do exactly the same for feature selection as in the next model. And there are many ways how to do feature selection for supervised methods, like for regressions or predictions. I can list at least 5 by default, but maybe the most popular for now is a method based on the machine learning algorithm called random forest, and we will get to it in the notebook, so don't worry. So a few additional types of clusterings, which actually I want to highlight before we finish with this topic. So first one is hierarchical clustering. There are a couple of different, there are actually maybe tens of different ways how to cluster things hierarchically. So first I will skip text and go to the visual so you get the idea. But generally, what does it mean hierarchical clustering? It means that in this type of algorithms, you get not only the cluster of each specific point, but you can get a different granularity of clustering. So for example, this visualization here is called dendrogram. And on the bottom line of this dendrogram is each specific observation. Each specific observation has, this is like hardly visible on this level, but it's merging with next neighbor, then it's merging with next neighbor, it's merging like a few clusters together, and this merging of clusters and cluster go to the higher and higher levels. So those small clusters here merge into higher clusters, higher clusters merge into a bigger cluster, bigger clusters merge into a huge cluster, and eventually all data can be covered by one big cluster, and then or a couple of huge clusters, or a lot of small clusters, and so on, and or a huge amount of very little clusters. So this specific dendrogram is generated based on the algorithm called word clustering. I think it's not the most efficient, but it produces a nice dendrogram, so it's good for intuition. And generally, there are two kinds of approaches in hierarchical clustering. One of them, in each of them, you are getting such a tree-based dendrogram, where you are getting the cluster, cluster of clusters, cluster of clusters of clusters, and so on. So the most popular method is called bottom-up approach. As I just discussed to you, you start from each specific point, connect them together, connect them together, connect them together from bottom, and you go to the up. It's also called agglomerative clustering. And it's easy to play with this kind of clustering. And it's easy to visualize. But it has a couple of disadvantages too. So first, maybe biggest disadvantage with this hierarchical clustering, and by the way, you also have it in your notebook and in R code. So you specifically, this visual is from R code, so you can try to rerun the R code by yourself. It's operational. But I think one of the biggest disadvantage for this kind of algorithm, at least in the word type, is that you, first of all, you should decide where do you stop. So for this algorithm, you should decide that, okay, I stop on this level, or I stop on this level, or I stop on this level. And it's not easy actually to figure out which level is exactly correct. The advantage is that you can actually build this structure in the few layers and say, okay, this is like segmentation of the first level, segmentation of the second level, segmentation of the third level. But it's even not the worst. Maybe the worst about this kind of algorithm is that in the process of generating this dendrogram, you should measure distance of everyone to everyone. So basically for each specific point, you should measure distance to every other specific point and find the closest, and then repeat it for every single point. Computationally, it's actually pretty hard when your data number of users are huge. So if you have a customer base which is around 50,000 people, that's fine. If you have a customer base in the millions, that's impossible. So specifically also this kind of algorithms often are used to clusterize text, because actually people don't use a lot of words. Every language is around 50,000 words. Fluent speakers are using 5,000 unique words, and like regular speakers, like who average person uses only 2,000 unique words in daily communication. So when you clusterize words or co-appearance of words, it's easy because you don't have a lot of different unique words. When you analyze customers, you should understand that this kind of approach will always have limitations, especially for a large scaling businesses like banks, retails, everything where like telcos, where everywhere where you have a count of clients like in the millions, that's becomes absolutely inapplicable. For a small data set, it's actually pretty good. Maybe another big disadvantage of this algorithm, you don't get a specific indication of what was exactly the distance between those 2 points, which is also pretty sad because, you know, let me, the most similar customer to me would be, I don't know, my wife, for example. In all terms of behavioral characteristics, we will be very similar and like almost exactly the same in terms of our buying behavior. Well, actually no, but that's my specific case. But I think you can find some person who is like super close, and this is the closest person to me specifically in terms of buying behavior. And we are one small cluster, right? But then for someone else, the closest person could be actually pretty far. But from point of view of algorithm, it will be exactly the same. Here's the closest, here's exactly the closest. Doesn't matter what was exactly the distances there, it's just the closest one. So this is like really big imperfections, because then you can not easily compare things which are incomparable. And that's why I think the most cool method which exists for now, and it was basically invented only in 2016, if I recall it correctly. I also included the algorithmic details in the appendix for people who like or enjoy math. Here I keep just the intuition and visualization part, but this is called HDBScan, not by coincidence. It's like pretty similar to the algorithm which we were talking about yesterday, which was called DBScan, right? And this is hierarchical density-based scanning. And remember in what we were looking for yesterday, So what we were doing, we basically, for every point, we were just checking if they're density-based connected or not. And if they are connected, then they were creating a cluster. In HTTP scan, you not only connect them, but connect and order them. And you start from the points where the density is the highest. So basically, if the density of most similar users are the highest, like somewhere here in the middle, and a bit less here, so the algorithm will start here and slowly will be creating such a social graph, or actually it's a graph or network, by connecting each next cluster. I think this is called a minimum spanning tree for this specific algorithm. And I have pretty nice visuals which shows it. So imagine that the customers in terms of two characteristics are distributed like the following way. So there are a lot of different customers, like hard to see some relationship, but the density of dots is differing by like different parts of dots. So obviously here there is a very little dots per square centimeter or per square. So density is very small. And the most dense areas are actually here. And then we have, in this algorithm, we have such a criteria called lambda. And it starts with the lambda, which is like very small. And then continue to grow lambda. Or lambda is a criteria, basically a threshold for a density. Well, actually, this notation for lambda is not like very, I mean, I don't believe that you will go specifically into the paper of the algorithm, but this criteria lambda is something kind of synthetic, right? So it's not really, there is no actually lambda in this algorithm, but it's just for explaining the intuition. But there are criteria similar like we had yesterday, epsilon and minimum points. But by regulating this epsilon and minimum points, you start with the highest dense areas. So nevertheless, so we start with these areas where the density is the highest. And we build this network. Like, first of all, I'm connected to you, then to you, then to you, and so on. And we create such a graph of connections. And then step by step, we relax our characteristics of lambda or of density, and our graph starts to grow. Yeah, I guess I didn't comment it, but I guess it's obvious that chart on the right is a density distribution of, let's say, X-ray, but this is like visualization like X and Y in 2 dimensions. This is like in 1 dimension what's happening. So anyway, yep.
Sorry, yeah. What is hierarchy in this case?
Yeah, hierarchy is actually built through like what's happening in background. Like we are starting from one point and we are like connecting with the next point, with the next point, with the next point. And we get this hierarchy from connections of different layers. So we get like, first of all, I'm connected to you, to you, to you, then to you, and so on. And the more this graph is growing, the bigger hierarchy you get. So eventually you get that, yeah.
So it's hierarchy within the cluster, not between the clusters, yeah? Because in previous, we had hierarchy between clusters, dendrogram.
On some points, there is hierarchy merge. So let me show it to you. So we also get it on the cluster level. So if we continue growing, okay, here we have 3 clusters, yes, like cluster 1 here, blue, then yellow, and then red, 3 different clusters. But then when we relax this lambda, those 2 clusters are connected, right? No. So they become one big cluster. So this bigger cluster is like a combination of this cluster and this cluster, right? And then we continue, and yeah, so this is actually also connecting the clusters too. I apologize, I need to connect my charger for a second. Yeah. So what's happening in the background of this algorithm, that you get this density connected structures. For now, I believe that this algorithm is probably the most useful thing we have in terms of combination of easiness to implement, easiness to run. This is also in terms of robustness, like stability to outliers and stability to other things. It gives us hierarchical view, so we are actually able to understand and like different level of segmentations. We have much less risk to be biased to some randomly picked macro characteristics, or for the clusters, like with the k-means, we always need to pick a number of clusters. It's not that stable. It's hard to keep maintain it. I think with the HDB scan, it's probably still far from perfect world, but it's probably the best we can use for now. So if you would ask like which algorithm should be eventually the clustering algorithm for customers, when you have a large number of customers, and that's my answer will be that for now would be HDB scan should be the algorithm to use. DB scan and k-means are fundamentals, good to have, good to know, and essential to know, but for now the most state of the art is HDB scan, and it's not used only for actual clustering of users. It's also applied for image clusterization, similarity detection in images, voice clusterization, a lot of different technical tasks which are done. It's often implemented on top of neural networks. So when or in the middle of a neural networks. But the basic idea is pretty nice and easy to use. So yeah, so here's like, I'll just go back again to the slide with the logic summarized. So let me just read what I see right now on the slide. So what we do step by step, we set the lambda to the smallest value of the core distances. A core distance is just a definition from technical definition from exactly this algorithm, but basically smallest distance from customer to customer. Filter the points in this level set, then you connect the points there at the most of in the most of lambda level connectivity, and then you create a new clusters and expand clusters and manage clusters, and then you can get a dendrogram. I think specifically Python or R is libraries not creating dendrogram based on the HGB scan automatically, but it's definitely possible to do if you really are willing to do that. Any questions about HGB scan algorithm? No. Okay, cool. So let's summarize about hierarchical clustering in general. And by the way, the one pretty good bonus on top of HGB scan is pretty well working with a large number of clients, which is good. So pros, it gives you a pretty detailed view on the customer prioritization and prioritization of different level of custom clusters. It's in most cases easy to detect closest customers. Not all algorithm will give you exact distance, but it's easy to detect closest customers. Most of implementation of algorithm is not easy to calculate for large numbers. HGB scan optimizes it, but anyway, like most of these algorithms are not well working with large numbers. It's hard to parameterize, and then the more complex things are, the harder is interpretation, of course. Then you like to your stakeholders, it's always important to explain, okay, this is our customer segment. But then you should have, okay, story number 2. Okay, this is macro segments. Let's go to the normal segments. So smaller segments of segments. And then we can go to the micro segments. So segments of segments of segments, which is maybe like gets harder to interpret some results whenever you go to some very detailed level or some row level details or some micro segment level details, because pretty often you can get a situation that, okay, this is our macro cluster. It's super good in reaction to this campaign. We send all of them offer with a discount of 10%. All of them take it. Everyone is super happy. So like big story is nice. You go to the more detailed level. Okay, say, okay, actually, 5 out of 10 clusters reacted great. 3 clusters reacted so-so. 2 clusters didn't react at all. And then you go to the lower level and you see, okay. So actually, I see that, out of this 100 micro clusters, I see that, 50 reacted well, 30 react. Out of those 30 who reacted so-so, they reacted, there were still someone who was really great, someone who reacted so-so. Out of those clusters who were reacting badly, some of them reacted negatively and stopped to be your customer because they were annoyed to get some campaigns and promotion and so on. So the more detailed level you go of these customers, the more complicated your story becomes, and then the more complicated decisions becomes, because you should be picky in terms of reaction. In the end of the game, as for me, it's always restricted not with the algorithms, but restricted with the ability to react on this micro or macro level. So if there is a technical ability and capacity to react on the micro level, you should definitely do it. But sometimes we know that this is not the case. Sometimes people say, okay, we will not be able to pick these customers and send something to that customers. So micro level for at least campaigns, not always applicable for some businesses. For online businesses, it's easy. For for retail stores, you cannot adjust some discount for one customer and not give it to another customer and so on. Okay. Any questions so far about hierarchical type of clusterings? Okay, I think we continue now. Or I suggest us to make, we are talking for 50 minutes, so I suggest us to have a 5 minutes break to keep a span of attention. And then exactly in 5 minutes, which will be at 10 in Ukrainian time, 10 a.m., we go to the last clustering algorithm for today and for this course, which is called C-means. Okay? So let's reconnect in 5 minutes. Hi, can you hear me again?
Yes.
Perfect. So I'm sharing my screen. 1 second. Actually, wrong screen to share. Yep. So as I promised, let's go now to the last part of the clustering, which we are covering for this course. What is this? I don't know. Yeah. So the last one which we'll cover for this course, and it's called, I specifically want to show C-means on top of everything else what we show so far, because I was keep repeating to you that there are some assumptions going with every algorithm, and generally there are a lot of different implementation of different algorithms. The assumptions which I say, there can be some pretty case specific for some specific algorithm, but there are always some alternative method which may be fixing this or that problem. So there are a whole field of segmentations and clustering, which is called fuzzy clustering. And the difference compared to the almost all previous methods so far is, I call it Schrödinger's customer. So probably most of you have heard about this popular experiment about cat of Schrödinger. That's some pretty popular experiment to explain the intuition of quantum calculations. And well, the idea of experiment is, like, I will tell the original story. So which like that they put a cat inside the box, they give some food, and then after some time they then don't really know if the cat inside the box is alive or dead. And then they say that, well, with some probability it's alive, with some probability it's dead. So theoretically it can be both alive and dead at the same time, right? And that's was intuition the Austrian physicists used in order to explain how this quantum thinking can work in order to explain the reality. And just a side comment, you know, that quantum calculation is like kind of hot topic right now. It's developing and scaling the capability of calculations a lot. It's still maybe on the stage of fundamentals. I think we just got some few big announcements over last year in this area, but generally it's a just more correct way to model the reality. It's harder way to model the reality, but also it's a more correct way to the model of reality. Because traditionally our computations look like, you know, you belong either here or there. It's like either yes or no. We know that especially when we try to predict the future, it's not always yes or no, but sometimes it's somewhere in the middle. And so back to customers, the idea is that some customers shouldn't always strictly belong to one cluster. So what we were saying, we had such big assumptions that so far that, okay, all our customers are like, you're either this guy or that guy or that guy and so on. Well, the truth is that all people are pretty unique and they can a little bit be like that, a little bit like that, and a little bit like some cluster number 50 and a little bit like cluster number 30 and so on. And that's where the idea of this fuzzy clustering came from. So the algorithm called C-means, it's pretty similar to what was K-means, which we explained before. It's, well, the current version of the algorithm was developed like 50 years ago, 40 years ago. So it's at least I'm not aware of some newest updates if it existed, but it has pretty much the same problems as a K-means, but like a few significant differences in the way how the engine of this algorithm works. So just a little bit of math, like extended explanations are also available in the appendix. Similar like K-means algorithm, C-means algorithm is also minimizing the sum of squared distances between every point and the center of the cluster. And then there is something new in this equation, which didn't exist so far. There is this parameter u here. So K-means was basically optimizing only this part. And C-means is adding this parameter, which is saying like the degree to which observation belongs to some cluster. And then for each observation, we not only calculate the distance to its own cluster, but actually to all clusters, centers, multiplied by some, let's say, the degree of how this cluster is belonging to this or that cluster. And eventually, we are in the situation when no user actually belongs to any cluster or belongs by some degree to every cluster. So just to give you an explanation, so visual intuition, that if you would have some clustering distribution of customers like this one, and we would try to show some density distributions of some characteristics. Well, we could model it like, distributions of one cluster, distribution of second cluster, distribution of the third cluster, distribution of fourth cluster, and you can see that like at least in this one dimension or in one feature view, the things are overlapping. Like this dot in the middle can belong here with some degree and can belong here with some degree. And then eventually we are getting the approach, again, very similar to k-means as we had before, but this approach is helping us to understand that every specific customer is unique, and it is possible to model this uniqueness or the level of belonging to some specific cluster. So if you would think about something like a recommendation system, well, what you can do? First, you can show the same advertisement to everyone. Second thing, what you can do, you can build some macro clusters and show this advertisement like to each cluster, like specific advertisement. But then what you can do next, you can, for every single customer, to figure out the proportion he's belonging to this, that, and that cluster, and show him some proportion of ads accordingly to his belonging to clusters. That's a place where things are getting a bit more complex. Also, I should say that this kind of approach has some significant disadvantage. It's not easy to calculate because it's you need to measure the distance of every customer to every customer once again, from every customer to every cluster, from every and so on. So this means that like number of calculations is a big, and then eventually it's slow. So this works perfectly for small amount of customers, or it's a, and by small again I mean when you still count it in thousands or like up to 100,000. It's usually such a of course it depends a lot on the technical restrictions, but roughly speaking, like whenever you try to calculate in the amount of more than 100,000 with some really complex, that start to be a problem. Till 100,000 clients, usually it's like should be still very okay. Well, advantage, it's gives you this level of similarity / dissimilarity, and you can get a dissimilarity of every customer to every customer. This is actually one step of that algorithm. So you can, if you have a relatively small number of customers, it is possible to measure how I am similar or dissimilar to you, simply by providing some distances. We were showing that like in most cases we use Euclidean distance. For c-means, there are more like sophisticated way of measuring it. There is a which is like called Mahalanobis distance. I don't think that you should remember the name, but the idea is that it's more or less actually sensitive and more robust to correlations. So whenever you have some data with a lot of correlations and you was not able to kick it out automatically, then c-means allows you to model things with Mahalanobis distance, or like at least in some versions. And then you can get a dissimilarity of everyone to everyone, because the bigger is distance between you, technically distance, you are also, this also means that you're more dissimilar. And that actually gives a lot of insights, because you can easily filter top 10 closest customer to this customer, top 100 closest customer to this customer, top 1000, and so on, or the most not similar customers. This is also super useful whenever you build the campaigns, or you try to build the treatment and control group for A/B testing, where you are like sending one promotion to one group, don't send to another group. You should make this some comparable results, and you cannot like the best way is to pick some two groups which are super similar, and this kind of cluster mirroring allows you to see that fact. Yeah, as I'm just, I think will repeat myself that, like, roughly speaking, it's good when your size of your customer base is like roughly speaking up to 100,000. The smallest amount should be at least 100, I think. The life hack which I developed for a couple of projects, I'm not sure if actually some scientists documented it or built a paper in it. Maybe I should write some paper about it on some point, but shortly, the good idea is to make a combination of k-means and k-means together. So what I did in a couple of projects for customer segmentations, actually, that I first clustered everyone with a k-means algorithm, and then I clustered clusters to get the similarities and distances between clusters. And this was actually super insightful and useful for a project. Yeah, that's maybe last point on the segmentations. That's like so far we were all the segmentation types which we covered. We called them unsupervised segmentation. So it's also fully unsupervised methods and so on. The truth is that it is possible to build also a supervised segmentations. They are more rare and they're not used that often, but does anyone recognize this visual and ever faced such, like ever had something similar in front of his eyes for some analytics? I see that Simon is shaking his head. Yeah. And yeah, that's called decision tree. This is also kind of one very basic algorithm which everyone applies actively for a lot of cases. But what's I don't want to deep dive into methodology of this decision tree algorithms, but roughly speaking, it's a it's a way how to predict things. So it's like supervised method, similar to regression in some sense, that you are trying to explain or describe why some things are like they are based on other factors. It is possible to use the decision tree as a way of segmentations. So basically, if you know your final target variable, like for example, later in this course, we will discuss usage of it for making customer cohorts for customer lifetime value analysis. And the target variable in that case is a combination of income and risk profile. And if you combine income and risk together and then try to explain them by some different factors, by risk, I mean risk of churn or risk of that client will not be client in future, not credit risk or whatever. So you put this in the target, and then you try to explain it by different factors. And eventually you get such tree, it's called decision tree, or with the leaves, where every leaf is a terminal node of this tree. And you're able, based on combination of conditions and rules, to get a cluster. This is especially useful because eventually you don't get, in this algorithm, you don't get some mysterious centroids, you don't get some, hierarchical structures, you don't get some things which are hard to interpret. Here you just get a set of conditions. Set of conditions, it's something which is always easy to explain and always easy to implement technologically for any kind of platforms or systems you have within organization. So as you can see, this tree has just a couple of conditions. Okay, if total savings and let's say less than 4 million, cluster number 1. Or actually bigger than 4 million here. It's not euros and not dollars, so the amount is not that huge. But anyway, so if it's like more than 4 million, okay, you get cluster number 1. Otherwise, if your savings are like still positive, basically this is like still positive and saving ratio is like doesn't pass some threshold, then here. If this and saving ratio is like this, okay, this is like a simple example based on the saving behavior, but like then you have such a different rules which lead you to a different clusters. And other popular methods which we are not mentioning in this course, but you may see.
Excuse me.
Yeah.
When I have a question for previous algorithm, how do you define the thresholds and the number of these conditions?
Okay, I don't define the thresholds here. This is part of the algorithm which is called CART. Classification and regression trees. So the simple intuition of that algorithm that it is trying to split all the data in such way that it's minimizes the also sum of square distances within each node, but it minimizes sum of square distances not in terms of like all features like in supervised cluster, but sum of square distances of the final target variable. So similar like in a regression, if you had the statistics course, you studied regression, you had this most popular version of regression, OLS, which is minimizing the sum of squared distances of errors between the prediction and the actual value. So similar here, but the way how it works, it's it picks every variable, and for every variable it is selecting such a threshold which will be the most minimizing this sum of square distances. Technically speaking, just to be precise, it's called informational value gain based on the difference in entropies before and after. But shortly speaking, it means that like it pick up this threshold such that before the split and after split, the data set is the most gaining in this sum of square distances. So and you get more. So this data set and this, like all this data set and all this data set, has the biggest win in the terms of sum of square distances compared to the data set which was all together. I hope I'm trying to
Yeah, thank you.
answer the question, but basically algorithm checks all possible thresholds. Not all, but it's actually automatically detects, let's say, 10 randomly picked thresholds, or like you defined by user. I don't want to go into all the mess in the engine, but basically it's checks all the possible combination of thresholds, which are like with some rational limitation. It checks, okay, what it would be the gain of this distance for this threshold, and it checks for second one, then it checks for third one, and so on and so on. And then it picks the one threshold which was the most minimizing this distance measure. Okay. I see there was some question in the chat from Oleg about ensemble.
It just was my comment that I think what you did before, yeah, it's some kind of ensembling, yeah, that you at first used k-means and then c-means.
Yeah, it's some form of ensembling of algorithms, but I don't know if it's like some the most well, let's say, if it's like based on some scientists finding it, whatever. What I do usually, it's already happened to me 3 or 4 times. When I find some good method, which is relatively easy, I start to do it. I practice it. I think, okay, maybe I should write a paper about it to get some citations, and then I find out that like someone wrote it like 3 months ago. Like, oh my god, that's a hell. And what I like about this industry in general, it's super actively developing. So most of things which we are using right now, they didn't exist 5 years ago. So when I graduated from university, it was not possible to know it because these things didn't exist, or a lot of things didn't exist. And that's the industry is developing very fast. Like something which was published like in October 2019, so like 9 months ago or 10 months ago, became super cool by January, became very popular by April, and now it's almost a standard in less than 1 year. Even some methodology or new algorithm which appeared, like now it's like almost a standard, and there is like almost every month there is some big significant progress in this area. So just to summarize, some algorithms covered today, they were invented in 50s. So they exist. Some were invented less than 5 years ago. A lot of them actually keep appearing and updating and finding new versions and so on. There is like whole big area of like with a lot of people working in that to crack this kind of cases. And fundamental stays the same. As you notice, like formulas in almost all algorithms were minimizing something. In most cases, it's a sum of square distances, but algorithmic steps were a little bit different. So what I'm trying to say is that like things may change, and you should just keep yourself updated. And there are day-to-day some new pretty cool things appearing, and there is no guarantee that these specific algorithms are universal for next 100 years. They're developing, they're evolutionizing. In 2-3 years from now, if you would want to rerun segmentation, you would have to just check for updates if there was something already smarter invented, which was like somehow killing one of these restrictions of limitation which we were talking about. There are a couple of other popular methods. Some of them I already mentioned. So for example, LDA is a especially useful method for businesses which has huge amount of products, or other categories which are, let's say, sometimes you have product categories, sometimes you have some, let's say, different type of channels or different type of sellers and so on. So a lot of different categories type. So in that case, I recommend for data science teams you will manage to consider using this approach, which is called LDA, is a latent Dirichlet allocation. And basically it's super good to understand how things coexist together. Recently I was applying it a few times. Even I showed you a couple of visuals how when in a platform people buying different categories of products, and you can easily cluster based on the product usage. RFM, this again, I'm mentioning it once again in our summary for our segmentations. And it's not an algorithm, it's rather a business approach. So always consider at least those three features, which stand for recency, frequency, and monitoring. I will again add this abbreviations. Recency, frequent, and monetary. Here we have latent and here we have the algorithm, which is becoming extremely popular, and I saw a couple of banking institutions already working on implementation of it. It's called SOM, so easy to memorize. It's a kind of form of a neural network or unsupervised neural network, which is reorganizing the structure of features. It's called self-organizing maps. Especially useful for mixed background features, because I don't know if you noticed, but all of features or which we were talking so far, they were numerical. And you know that like in real life, some data is not really numerical. There is time, there is categories, that there are some other additional features, like for example, in your business, for some whatever reason, you categorize people by categories, I don't know, new, old, coming from that background, and so on. So it's basically a category of text. And all features, all the algorithms which we discussed so far, they don't really work well with the categories. All algorithms work well with numeric data. Like one of like this, not really super new algorithm, but it's becoming very popular. Is this self-organizing maps is the one which is like working well with the categorical data. And LDA is also working well with the categorical data. And yeah, I'm not aware if there is some super successful implementation of SOM in Python or in R, so definitely not available in like this BI tools like Power BI. There should be some good implementations. I know about some implementation. One of my colleagues actually did from Amazon. It's publicly available, but I'm not sure how standardized it is that so far. So some scientists, some separate scientists like do it or implement it. I know that some banks invest resources in order to develops this clustering algorithm for themselves, but I'm not sure if there is like open source, standardized, publicly available, and so on. Yeah. So let's maybe, it's a good point to summarize everything about the segmentations and move to the next topic. So let me open a slide here and let's try to write a summary altogether. Actually, I wrote already some summary, but I wrote the summary questions for you. But I will add a summary from you. So, and let's scale it to smaller to give us space. So I added some, let's say, questions which may be good to check if you remember how to answer them, but let's try to summarize everything before we move further. So,
So first, there are plenty of different algorithms, yeah.
That's a good conclusion.
To make segmentation, clustering. Important that it's unsupervised learning, yeah.
Always make a mistake in these words. Yeah, so most of them are unsupervised. So which one did we cover so far?
K-means.
DBScan.
HS DBScan.
And C-means in the end. And also we slightly mentioned that there are other exist. So we mentioned the hierarchical award algorithm, there are SOM, there are LDA, and there are plus, 1 million more different versions of the algorithm. Those ones are just the most popular one. What else was like key takeaway from this part of the course?
You have to choose algorithm based on your problem and take into account capabilities and customer base.
Yeah. Based on big problem. And there are no universal algorithms which will automatically answer all of your questions. So there are no, magic button where you click one button and you got all answers. That's for sure.
But may I add? I also remember that if we are going to work with geodata, DBScan is better.
Yes, DBScan is better for geodata. And other, we call it non-convex data. Like the data which can have weird forms, where like more is better or less is better. It's hard to say because of lack of linear dependencies and so on. I see Ari added the point that like you can combine C-means and K-means. You can combine and clusters. That maybe I would add one additional point, that hierarchical clustering is more challenging but more insightful. Anything? Okay, so
That
Yeah.
HDBS scan is current state of the art. Yeah.
Yeah, it's maybe one of the best existing things
At the moment.
Yeah. Okay, so final point on this part. So we have a pretty good summary, I think. Final point on this part. Well, maybe those things will not be useful for you because I placed for you the notebooks here for segmentation, for R and for Python version, and also segmentation file input. With the Python version, you can run it in Colab. It also has parts about HDB scan and cmeans extended. So I will not rerun right now, but I will just walk you through that. Here you can play with this HDB scan implementation. And here is like just one visual how to pick the characteristics of a minimum cluster size in HDB scan. Like, doesn't really matter, but like shortly you have here the short implementation of HDB scan. So I would really encourage you to rerun the notebook at home and share your results, and preferably try to plug your own data into this notebook, or create a copy and rerun it with your own data, which you have from own business. Also here you have a couple of functions implemented for cmeans and selecting the number of clusters for cmeans and so on. And also in the end, I was showing you this algorithm for supervised clustering, which is called CART, which is also actually implemented here within this notebook. The visual here is different from the one which you saw in the slides, because the one which you saw in the slides was implemented in R and this one is in Python, so the visuals don't exactly match. But you just like try to invest some good time into running those notebooks and trying to understand how those things work. Yeah, as you can see, those trees can be pretty detailed. It's like a whole different area, the trees itself. But I guess the most important for you to understand that it's possible and its limitations. Also, final on the segmentation part, I placed all the math part into appendix. So in appendix, you have a reminder about the distances type. You have a little bit more mathematical details about how k-means work in background. And it's specifically specializes about how this, what are the algorithmic steps and how does it minimizes the minimum distance, and extended version of the formula written here. it also has a more detailed explanation about algorithmic steps and definition of dbScan. So actually, there are a whole area where we structures the different type of dots in or customers in HDBScan. So we just split them on those customers who are inside the cluster and who is in the outside part of the clusters, and those which are reachable and not reachable. And also, yeah, some additional details, and also the same for HDBScan and algorithmic steps, and also for fuzzy clustering. Again, additional details on how exactly do we define this level of similarity. Yeah, I think that's it in the appendix. I don't want to make it too heavy with math for our class, but if you have, if you're interested, I'm here to answer the questions which you have right now or you can have in the future. Okay. So
do you have some recommendation for where to get such customer data?
Usually CRM system, if you have a CRM system inside the company, is the best source for
I mean some public available data sets, maybe also like in Kaggle there are sometimes some data, yeah, but
okay. Yeah, I don't.
Maybe Amazon has public available data sets. I don't know.
I'm pretty sure that Amazon doesn't share anything publicly, but there are maybe possible things. IBM from time to time publishes the public data set. Microsoft is publishing public data sets. Amazon, to my knowledge, I'm not representing Amazon in this sense, but I am almost never shares anything publicly. And then there are Kaggle. I can make selection of it's usable for such exercise which are available in Kaggle. And then what I can recommend, you still see my screen, there is such a resource built by Google. So just called Google Dataset Search. Yeah. And you can put here, like it's a search across different academic and business data sets, including Kaggle and all other sources. So you can just put customers, I don't know, random word customers. Okay, you see it's searches data sets, mall customer segmentation data. Here you have. Second one is a number of Vodafone mobile customers in Europe 2020 by country. I'm not sure what the level of detailization. I would most probably recommend you to use the Kaggle because they at least keep track of what's going on and keep the standards in Kaggle. But I don't know, maybe there was someone in the group, I forgot who exactly was working in Ukrainian statistical office. So maybe you can get some good data from there too. Yeah, so telco customers churn. We will talk about churn also, but I mean, there are a lot of publicly available data sets which you can find here. Yeah. So as you can see, simple search gives you a pretty good selection of possible data sources. Okay, so any questions to me before we move further away from the segmentations? Do we need a 5-minute break after 45 minutes, or we are fine to continue with the next topic? Okay. Okay, I will be very more specific in the question. Who wants to have a break for 5 minutes? No one wants to have a break. Great. Oh, one. Kirill. Kirill, if you stay minority, we will not have a break. Okay, Alina. Yeah, I think okay. I believe more people will type it, so let's have a break and for 5 minutes and meet in 10:55. Reconnect. So just drink some coffee, water, and we are back for next part.
Okay, thank you.
Hello, can you hear me and see me once again? Hey, so can you hear me?
Yes.
Cool. So today I then suggest to switch to the next topic, which is, let's say, the most universal one, the churn analysis. It's a big topic. We will cover it today and tomorrow, and also switch to behavioral scoring tomorrow. Scoring is just is a smaller topic, and it doesn't apply for every single field. So it's maybe more typical for sure for financial services and for telcos, maybe for energy and utilities too, but definitely it's less applicable for like startups or e-commerce or something like this. So we will let's start with the churn as a topic which applies in every single business. So quick check, you can find the slides in the same folder I shared yesterday. And it has a slide, syllabus, and notebook structured by topic. Do you have access, all of you here? Okay.
Yes.
And the link which I just shared, churn, also you have access, right?
It works.
Oh, cool. Perfect. That's already a progress compared to tomorrow. The most important to keep progressing. So, maybe let's start the same way as we started with segmentations yesterday. Who already faced churn analysis in own organization or for some specific needs? if you could share your experience related to the churn analysis. Anyone?
I mean, we had some training examples during previous classes, but on this, I didn't start this process yet.
And in business, did someone try to apply it or use it for something? Okay, that's well. Let me start. I think that the churn analysis is most widely applicable use case for analytics. It is applying to every single business. And the idea is that basically you predict whether your customer is still your customer, if he's still loyal, if he's like still keeping visiting, or you're predicting the event when he stops to be your customer. Probably that's the most important part of business altogether. So what we are going to cover in this part, we are going to have a discussion at the beginning about the churn analysis in general, how it applies, how beneficial it could be, which kind of data is important for churn analysis. Then concerning the methodology part, there are actually a few different approaches how to go to churn. I prepared 2 examples and 2 like workshops, one in R and one in Python, which are different. One for telco and another one is for e-commerce. Just the one from telco in that case is provider of the data is IBM. And I noticed yesterday that they changed some access restrictions. So I'm not sure if like all people will be able to load the data set. So I suggested today we will start with e-commerce and I will try to offload the data and give access to everyone. So we will be able to discuss the telco example tomorrow. And also those 2 examples, they are different in the approaches which we will take in order to solve them. Concerning the theoretical and math part, we will cover the approach which I believe is the most universal one, which is called survival analysis. So let's start. As I told you, my understanding is that the single unit of business is customer, and every business is as good as many and as good customers it has. And the churn is trying to answer pretty scary question: how fast you are in losing your business, or how fast you are in the losing your clients. Basically, churn is a kind of business definition of the event when people are not happy or and stop using the service or a business for some reason. The problem is that in most cases, they just stop using the service without giving a feedback. So you don't really know what's going on. So they don't tell you. They just stop using the service, and it's hard pretty often to understand what's going on. So in this picture, you see that like there's a store, people are running away. They say that terrible service and friendly stuff, but they don't have, but the owner have no idea what's going wrong there. And it's also most of companies are tracking this metric as a churn rate. So how many customers out of total customers are leaving the business every month. And this is a very important indicator to understand how happy or unhappy customers are. So being super precise, so customer churn is when customers or subscribers stop doing business with a company or service. As I told, this is pretty universal. I saw different implementation of churn predictive models across all areas. I think maybe the only case when churn is not applicable is when analytics is not applicable. So like in B2B businesses when you don't have enough customer base for analytics. But in all B2C, C2C businesses, this is absolutely useful and essential metric to have. So basically, the core goal of this churn analysis is to predict that some very specific individual customer will stop using the service, and preferably to predict it upfront and enough time in advance. What is enough time in advance? It can vary by industry. So for online businesses, it can be 1 day in advance. For banking, it is 6 months in advance. It's just also pretty hard because sometimes the reason why people are leaving the company can happen within that period. So it's hard to explain it upfront, really. Second important thing is to be able to understand the causal effect, what actually caused that that kind of event and what was the trigger. And of course, I guess it's obvious that it's important to be able to make to be able to take some action to avoid similar events in future, or maybe retain the customers in general in the customer base. There are a couple of assumptions which should be applied before we are able actually to analyze anything. So one very popular assumption, which is actually in most cases makes sense, but I'm pretty sure that it's possible to find an example when it's doesn't make sense. But the idea is the following: so that clients have a life cycle. So for every single product, you are starting to be a client, you exist as a client for some time, and then for a natural or reasons, or because you are not happy with the business, you are not customer of that business anymore. So let's think like what actually, when it's actually not true. Like I'm thinking if like this is definitely true if I am some service which I'm using pretty often. So if I'm using taxi service, let's say Uber, here's a disclaimer, no offense Uber, just as an example. I download the app, I use the app, then I don't like how Uber works, or I don't like the pricing, then I delete the app, I upload, I don't know, in Ukraine, second most popular one is Uklon probably, or I don't know, or Lyft or whatever else exists right now. But then I download alternative app and I use alternative app. So I have a continuous need for this service. I use it a lot. And that's why I have some kind of life cycle. It wouldn't apply if, for example, for business of furniture. So I buy sofa, I don't know how many times people can buy sofa in their lives, but I don't think that someone is buying more than 3-4 sofas over the life. Depends on how many houses we have, but like average person doesn't buy a lot of sofas. So in this sense, it's hard to think about me as a customer of the furniture company from life cycle perspective. I just either buy it or not. But for most businesses, it's applies. Second assumption is that churn is the end of this life cycle, and we try to predict end of this life cycles and triggers. Third assumption is that churn is rational. So it is possible to explain or predict based on the data or based on available data. Obviously, there are a lot of cases when we don't have enough data, and when also possible when churn is happening unrational, like people just, let's say I lost some key or password to my SIM card, and I don't know, for whatever reason, I just decided to buy a new one. Not like I was unhappy with the previous one. Okay, this is like more rare example, but that like I would just lose it. But there are cases when there are no rational reason which would be able to explain churn. People just stop using it, or I don't know. And customer behavior is like probably possible to track in data. I remember like a couple of years ago, I used to cooperate with one big Central European energy company. And we had a presentation, there was a presentation in front of like big bosses. And there was one very junior but very ambitious data scientist who proudly told us, oh, I found a very strong predictor for churn. And then, okay, everyone is like intrigued, like what is predicting our churn so well? And he said, okay, I found that customers who are more than 100 years, they are going to churn soon. And so the idea was that it's hard to, because you are muted, it's hard to see if you got the humor or not, but I think that the idea was that, you know, people, because they're so old that there is like, they will churn from life soon, but not only from service. But yeah, this is a strong predictor of churn, definitely. Not very useful, not very actionable. We cannot do anything about it, but this is a strong predictor. Yeah. So there are a couple of actual ways how to look on the customer life cycle. Let's take the most universal one. Maybe I will also mention a couple of alternative ways how to think about it. So for an average business, we can think that there are some sales efforts at the beginning. So you have some negative profit you're investing in the customer. Then he is converting to an actual customer on some point and starts to be profitable and bring some positive profit to the company. And then he stays for some time, and on some point with a run of time, his profitability from this customer starts to decline. And this is like first alarm when we want to predict future churn. For some scenarios, the customer can go down and go to the churn event. Maybe there can be some active retention offers, and then the customer is staying. Like, so for example, I think good example is actually job market. And people are not happy with their job. At the beginning, they work a lot. they produce some output, and then they're not happy, their productivity declines, and then you say, oh, I'm going to leave the company. Then probably your boss comes to you and say, oh, you're such a valuable person, we increase your salary, so this is a retention offer. You say, oh, actually, yeah, okay, I'll stay. In some cases, the people don't stay with the retention offer. In the marketing sense, it can be additional service, it can be some extra bonus, it can be a discount on some service. For example, the credit cards. When you go to your bank and say, okay, I want to cancel my credit card, so I don't use this credit card anymore. They say, no, we will add you some additional services. Now you can use your credit card in the lounges, in the airport. So now you get some additional higher cash back on your rate and whatever. They try to make your conditions a little bit better. So you'll be a little bit less profitable for them, but still going to stay as a client. So this is the example of retention campaign the companies can have. Yeah, and then so the focus of churn analysis should be here. So from this point, when the customer became a very well profitable, you should be keep eye on him and make sure that he is super happy about everything. Then this proactive retention part is initialized when churn triggers are predicted or identified. And then there is this stage which is called reactive retention, is initiated upon client's request on the service termination. So the best scenario, I guess, would be to, before client is unhappy and comes to you, to change a condition in the way that he is happy and so on. This time window, as I told, this can be pretty business specific. So that can be just, I think maybe such a golden rule would be to check the average lifetime of the customer, duration of the customer stay, and then check if second part of that lifetime. So what can be actually churn triggers, the things which we are going to identify with the churn analysis? So first, you're trying to identify the dissatisfaction with the product or service. You can try to identify the change of the customer behavior or needs. So maybe client is absolutely happy about something, but now he needs like something else. Like one good use case when people have a big transformation in life, like for example, graduation of college or marriage, is like changing our buying behavior a lot. And sorry, I will be keep giving examples from banking as it's easy for me. But like when you graduate from college, you most probably have just or from university, you have just a, your debit card where you get your contribution from parents or some first job or something like this. Then you graduate, you start to travel, you start to get bigger incomes, you start to spend more time because you have a first job. So you maybe need to have some card with a good cashback. Maybe you need to have a good credit card for travels. Maybe you need something else. Then you marry, and then you need to have a house. So you start to look for a mortgage, for a like bank who can provide a good mortgage condition and so on. I know that mortgage doesn't work well in Ukraine, but in all other markets, this product is quite popular. Actually, fun fact, except Italy. In Italy, mortgage doesn't work at all. So in Ukraine is not the only country in this list which doesn't have working mortgage products. In Italy, I don't know how people buy houses. I have a feeling that in Italy there are much more people who are seniors and young people. They just get a heritage, so they don't buy houses, but they just get them. But in most of markets which are actively growing and developing, the mortgage is probably the most important product bank is delivering to customer. Then there is what you're also trying to identify is a competition or market condition change. So maybe your customer received some offer from your competitor, and then that's already the final stage when the customer is actually requested termination of products. Maybe a good example will be internet provider. So like when you, like it's a basic internet provider, so basically utility companies for now. And people have a contractual relationship with the internet. So in order to stop being a customer, you're not just stopping the buying things, you just need to go and ask for termination of the contract and ask to install. So the thing which you're maybe you will not see in the retail because people don't come, but in a lot of cases when you have a contract, termination of contract, that's what you would try to predict. Then there are such inactivity triggers, which also you try to keep attention on, is unethical sales, ineffective and inefficient after sales process. Then a lack of proper information for customer, and when the customer gets the offer of mismatch between what he needs and what he expects. So how we are going to model all this situation is basically we are trying to model a time between first transaction from customer and the last transaction from customer. And here's the first problem which can be associated with it is let's say it's easy to understand what is last transaction for a customer who has a contract. So he just terminated the contract, say I don't pay anymore. That's easy. What about people who doesn't have a contract, for businesses which work without contracts? Let's say prepaid telco SIM card or online service where you just like either you enter or not enter. How would you identify this last transaction case?
If date of the next payment is not, let's say, if the next payment is not coming for the time period, which is more than maybe some average for previous periods, something like this.
Yeah, more or less it works like this. The most of telcos, they don't consider you as a client if you're not active for 6 months. And then these things, they have still technical restrictions, and after 12 months they deactivate your card at all. But from business perspective, if 6 months you don't make calls, it was the last transaction. Then there are problems because you need to wait this 6 months in order to realize that your customer actually churned. Because if his last transaction was 1 month ago, you don't know, was it the last transaction or he's still going to come back? You don't understand how to treat them. In the statistics, it's a problem, or this transactional data. There is a definition called data censorship or right censor of data, when we are basically censored by the current reality and we don't know what's going to happen next. So let's discuss a little bit the chart modeling. So which data sources we will need, how do we process the data, which kind of modeling strategy we can use, and how can we use insights from the model. Churn is obviously a problem which is supervised. So we predict the event, a very specific event based on different factors. For sure, I think this course altogether will not be enough to explain all possible supervised techniques which are applicable for this solving, but I think I will pick the ones which are the most often used for churn specifically, or for which are the most useful for the problem associated with churn. So data sources. So typical steps would look the following way. So first of all, we should shortlist the data sources. First of all, it's a customer interaction data, which means that like all communication with customer, if you have a chatbot, then all history of communication. If you have a call center, then history of communication is call center. If you have email communication, then like history of emails sent, offers, and so on and so on. So everything what was communicated ever to the client. Second one is customer behavioral info. So how the customer behave with a service. Third one, maybe it's actually should be first one. In most cases is a customer transactional data. When the customers are going to do like all the history of transactions done with this customer. Like I think transactional data is the only universal single data which available in every business. So it shouldn't be the problem. Customer financial data, it's maybe the industry specific. Not every client is asking proof of incomes or providing. Demographic data, which is including the address, the gender, age, family constitution, and so on. For banking specifically, there are always data from credit bureaus and publicly available, or not publicly, but basically third-party available scorings for every specific customer. In this sense, banks cooperate a lot. Right now in EU, it's going to be, or it's already much harder to get the third-party data because of the GDPR standards, which started to work last year, I guess, I believe, or already 2 years ago. I'm not sure how GDPR is like applies for Ukraine, for example. In USA, they don't have a GDPR, but in USA, in California, they have much lighter version of GDPR standards. So you still can get some information from the third parties with no problem. In Asia, it's in Middle East and Asia, it doesn't have any kind of regulation in this area, which is like really funny. So I should tell the story about one bank in Vietnam. It had some European roots, the bank, and my colleagues who used to consult that bank, they told that like, what do you ask actually from your customers in order to collect all information about them? And they say Facebook ID. That's it. I say like, really? Like you don't need a passport ID? I know, you know, a Facebook ID in Vietnam, you know everything about the person. So you can collect all the credit data, you can get all the any kind of business cooperation. You can get the passport details. And so there is like a zero level, or at least it was at that moment, there was a zero level of protection of personal data in Vietnam. And like true is that in all the developing world, the level of data regulation and restriction from the third parties is by far not the same like in EU. I'm not sure if EU regulation in this sense applies to Ukraine, or if Ukrainian associate membership is including data regulation. I'm actually not aware. Most probably it applies, but doesn't work de facto. Does anyone know if Ukraine applies GDPR? Yeah.
Yes, I think no.
In banking system, there are a lot of banks with foreign capital. That is why all those banks apply GDPR in Ukraine.
Yeah, because they are international banks, right? So if they are European or European headquartered banks, they should be following EU regulation by default in all territories. But I know that some Ukrainian banks really violate this hardly, really even badly violate, unfortunately. But this is like purely Ukrainian banks. So call center interaction, point of sales interaction, especially valid for some local shops or retails and so on. Then mobile platform interaction, if the business has a mobile app, web service, this is all trackable and easy to use for a channel analysis. So how much people actually are generating this kind of data, and if it's they're stably generating, if you are able to see that person stops using the mobile app so often, that's a bad first signal or first trigger. And then marketing campaigns, or response to marketing campaigns. So obviously the best user is a user who answers all the calls and clicks all the links sent by a customer. And if person is like automatically assigned the marketing campaign to trash or to spam, that's probably a really bad sign. So usually, depending on the data availability, you try to collect such a pretty big list of all the possible features. I think in most of my projects, it was like around 200, 300 features, which we were able to collect and apply. And then you do the feature selection exercise. If you wish, I can cover or add you material about how feature selections work. But there are a couple of machine learning techniques how to do it. Simple ones like regularization, lasso regression, ridge regressions, and to complex ones which include dimensionality reduction, map reduce, maybe tree-based importance scoring, and so on. That's a like pretty big field. In most cases, when everything goes well, they should answer more or less the same. In this exercise above telco, I will show you how the feature selection works for is the most popular approach for now, which is this random forest-based approach of feature selection. And then important then is once you build the features, you train the model, and you should keep track on what's going on, and then you can use this churn For next step analysis, you can see the churn usability by reaction to campaigns. You can all the time track the churn probability drivers, like what is increasing or decreasing churn probability and so on. And again, in the most cases, you are getting stabilized with a pretty small amount of features. Ideal case scenario is something like 15 to 30, or like 30 is like will be top liner. I remember that like once in my career at the very beginning, I did the model which included 150 churn predictors, and this was, let's say, hard to maintain, because then you should maintain a lot of data sources in the good shape, which can be actually pretty costly process. So and that's why as simple model you have, as good for maintenance it is, but at the same time it's always a balance between accuracy and complexity, so, or easiness to follow. And also, obviously, a lot of methods of machine learning which is possible to apply to predict something are not good enough in order to understand the drivers and the contributors of the churn and so on. And especially with churn problem, for sure we need this explainability part of machine learning applied. So we either apply simple models which are easy to explain, or when we apply complex models which are accurate, we should also invest enough attention and time and efforts into explainability of those complex models. So some comments on the data preparation. Usually it's most of the project is all about the data preparation, and or most of any churn analysis will be always about the preparing good enough data, making it stable, clean, fully applicable and replicatable. Usually you deal with the panel data with this kind of problems, and it should be possible to do it as a panel data. For those of you who ever did economics or econometrics training, you know that panel data is can be painful sometimes from a point of view how do you interpret it, but or which method to apply to avoid the bias in the panel data. But shortly, for those of you who didn't do the trainings in econometrics and economics, panel data is a data when you have for every customer and every point of time, you have a history track. So for example, if you work with the transactional data, and there are days when customer doesn't do any transaction. I don't think so. Sorry, Ari, what your comment is about panel data?
No, it was about GDPR in Ukraine.
Okay, sorry. I'm somehow reading it with a significant delay. So yeah. So panel data is like sometimes you don't have a transaction every single day. Yeah, so you should, but your data should be panel data. So you should have a record every single day. So you should make sure that when you pre-process the data, if there is no event, you keep tracking this as a zero. That sounds like a basic, but actually it leads to a lot of confusion because of the way how most of technology works, and the people will just take Excel or SQL and aggregate the data from transactions, for example. You should keep track that, like you keep a record for every single customer in every single period. In most cases, in most businesses, it's a monthly granularity data. And you it's good enough to have like all the values based on the months. I believe that there are some businesses when they should be more granular, like on the weekly or a daily level. Maybe a daily level is really something like super demanding, but weekly level probably for online businesses is more meaningful. Yeah, so next one is you should be aware of information leaks. And so as I already mentioned, one problem that data sometimes it can be right censorship, sometimes it has internal censorship and the data is not available somewhere in the middle and so on. And it's always hard to measure some good triggers. In most cases, people just don't communicate. The reality is that when you build this kind of churn prediction, you have most of your data actually are zeros. So when you will try to segment customers, you will realize that you have a lot of customers who have low activity, and it's usually 30–40% of the whole customer base, which are having like all the data as a zeros, like zero activity, zero triggers, and so on. And then the last, and it's already a statistical problem, it's a problem of unbalanced data sets. So what does it mean? It means that usually when you try to model something, the perfect case scenario is that you have a 50–50 split of the data. So, I mean, when you try to train a machine learning model, ideal case scenario is that you have 50% of good customers, 50% of bad customers. You predict it and try to train the model based on prediction of those customers. And again, the reality is that in a lot of problems, not only in churn, but especially in churn, you don't have this balance of 50–50. You have a balance of usually like 5% to 95%. So 5% of customers are actually churning, 95s are staying, or 99 are staying, 1% is churning, which is making this kind of problem to be, I mean, that you should be apply such a techniques which are okay with the high imbalance of the data. Because otherwise you can say, imagine your churn rate is 1%, your retention rate is like 99%, and when you say like, okay, how many actually customers are churning? And you say like, no one, everyone is happy, and you're already right by 99%. So like you don't need the model, you just say like, all's fine, and you're 99% right, but doesn't mean that there are no problems actually. It just means that like the models we will use, they can be significantly biased based on this imbalance of the data sets. There are basically three big topics or three big ways how can we model churn. So first modeling way is something like in the machine learning, it's called a binary classification. So the benefit of this method, I mean, did anyone do some kind of binary classification by now? I believe that in most of analytical problems, you do something like a binary classification. So yeah, so in binary classification, you can apply a lot of machine learning models. Like it is, I know you can start with the regressions, then you go to decision trees, then you go to the random forest, then you go to extreme gradient boosted trees, then you go to neural network classifiers, and so on. And you can just continue with 100 different methods how to classify and predict this. I will, it's hard to explain in the simple words for me, but I will try. So the problem for a churn of the simple binary classification, that you should classify all customers on the churners and non-churners. And that's obviously those people who already churned, right? More than, let's say, more than 6 months ago. It's super clear. They churned once 6 months ago, they're not active. Okay, they're non-churners, they're churners. Second, you should take a good customers. So good customers who like very active, bring a lot of profit, no problems with those customers at all. And then the last one is when you try to classify like those people who are somewhere in the middle. And those people who had transaction 1 month ago, but it's not really clear whether they are actually alive or not alive and what's going on and so on. The problem is that in some cases it can be pretty significant amount of such people who are somewhere in the middle. So if you take the e-commerce, it can be up to 30% of the all customer base, which is a lot. That's why binary classification is working well when you can exactly know if client churned or didn't churn. For example, telco. And when you have a contract with your, if it's postpaid telco, you have a contract. Sorry. Yeah. So you have a contract, it's a postpaid telco, it's easy to understand if customer is churned or not, if he is still alive and so on. So it's easy to do this classification. For other businesses like e-commerce, this doesn't apply. Again, this problem is called right censorship data, and survival analysis is like one way to fix it. So we will talk today a little bit about survival analysis. And then there is this trigger-based modeling, which is, again, did anyone try to apply the methodology called Markov chain? It's especially popular in finance. Our finance people usually know it, but it wasn't created for finance. I believe in marketing, it also applied a lot and so on. But shortly, for those of you who are not familiar with the Markov chains, this is the method to model people in the different states and their transition and their probability of transition from state to state. As for me, it is a big simplification to model customers through the state-based conditions. Usually your states are your segments, which you generated in the, like, based on something we had before. And you say, okay, customer is migrating between segments across time. So he's migrating here, there, here, there, here, there. And then one segment which you will have is like a churn segment. And in that methodology, you will have the transition from every segment probability to churn. So you'll have a segment level view, and that will be kind of, in the most cases, will not be precise enough. Yeah, and the last my point of the modeling best practice in this case is churn is really needs explainability. So simple model works. More complex models, more complex explainability. Everything what is action-based requires high level of explainability. And there are some new technology developed by Microsoft, publicly available. It was just published or updated this year, which is called Econ ML. I didn't try it so far. I can type it for you in the chat so you can Google Econ ML, which they promise it's possible to apply in one integrated solution, high accuracy and good explainability. But let's see, because I pretty much understand how they do it, but I have some critical points how this will work. I know that also Uber developed its own version of this solution. I don't remember exactly. I think it's called Causal ML. Causal ML from Uber. It's also a publicly available technology. It also allows to apply a methodology which is like pretty complex, like assembly methods and neural networks, but at the same time to get some good level explainability over the causal factor. I specifically actually specialize in this causal machine learning in my work, so I'm deeply in the topic. So like if you would want to learn more details, feel free to ask. And now we will go to the, I will skip the implementation part, but I will just give you an example of how the churn analytics can be helpful for a real business. So a couple of years ago, there was a project in the Central Europe for a banking industry. And in that project, the managers of the bank noticed that they start to lose 16% of the revenue annually, which is a huge amount. Maybe a lot of banks actually face the same problem. And again, I'm not sure how profitable this product is in Ukraine, but like, for example, in Central Europe, like in Poland or in Czech Republic or in Slovakia, Hungary, Romania, Baltics too, there is this product called cash loan. I know that this cash loan also exists actively in Ukraine. I'm just not sure how important is it for Ukrainian banks, but for banks in the region, it's a super important loan because on the cash loan, when you take money in cash, you get a super high interest rate. People often forget to repay it, so they get extra fines. So it's super profitable for bankers to give cash loans. It's a very small amount, but high profitability for those products. And so they started to notice that like they started to decline a lot in the revenue. And pretty simple churn analysis. So we just started to check why people don't use cash loans anymore. Showed that like 30% of that amount actually could be saved. And this was like also shown that like there was like systematic churn problem. It was not something like a seasonal trends. It was not something like of the impact of the third-party factors. It was related exactly to the user experience which customers were getting. And some pretty short analysis was able to save some significant amounts of money. I even have noticed somewhere how exactly it was possible to save, but basically it was possible to predict the churn around 6 months in advance. So like basically all the customers were split in the segments. For each segment, there was a separate churn analysis. It was split based on the profitability of different clients. And it was possible to save a significant amount of money. So if I'm, this is something what I just like got from the client itself. So like altogether, it was around. I think I'm missing millions in this slide. So yeah. So roughly speaking, I think I have some mistake because I'm missing millions in the slides, but roughly speaking, the level of numbers was like in tens of millions, what was possible to save overall during this project. I will skip now this example with the churn in telco. We will start with it tomorrow. As I told, this was the data available from IBM, and it has some restrictions, but I will switch to the last part when we go a little bit to math, and then we'll try to model that math. Okay? Do we need some break before we go to the math?
Yes.
Yep.
Yes, yes. Okay, cool. Okay, so let's have a 10 minutes break now. We had this short breaks for 5 minutes. So like let's meet again in 12:05 and make the last session for today very intensive. Okay?
Okay.
Thanks.